Okay, longest palindromic string. So we're given an S, and we return the longest palindromic string, which is a string that's the same forward as backwards. This is a medium. This is actually pretty challenging. It's not like intuitive. Good evening to cast. Yes. The cast. How's it going? ABA is also valid. I'm doing alright. Surviving. Just trying to pass the time. Yes, I have an interview tomorrow. Tomorrow afternoon. At Camo, I could use ChatGPT, but I'm trying to avoid using AI. I really want to think about it, because I'm thinking about interviews, and during the interview, I feel like it's kind of a dev work already or breaking into the field. I recently just got I got let go from my previous job about a week ago, so I'm just trying to find something new. Let's do it without GPT. Let's do it. Computer science student. Nice. 4th semester. If I'm reading that correctly. Awesome. Yeah, LeetCode is really good for sharpening your skills. But yeah, it's been a while since I've dived into LeetCode. I have like 10 years experience in the field, so it's been a while. Companies don't really do traditional LeetCode anymore. They do more practical coding, especially if you do like UI experiences. So they usually ask you to build like actual programs or websites and whatnot. But sometimes you get surprise old school LeetCode challenges. It's good to be able to think through them. Have any advice? So usually my go-to strategy is to be able to think in parallel while you solve a problem. So for example, I think it's always better to get a solution really quick, even if it's bad, if it's slow. Get the solution super quick, because this one, it is possible. You can say like, let longest seen so far is an empty string, and we could just return longest seen so far. And basically you could just do a very naive, very basic solution that just gets an answer on the paper, because I think that's the most important thing. Is you don't want to struggle getting the perfect solution right away, because you end up not getting a solution at all, and that seems to me to be anticlimactic. So I think it's better to just think of, even if it's n squared, n cubed, n to the n, no matter how bad the complexity is, get an answer on the paper, get an answer on the whiteboard, get an answer in code. And then while you're writing that, you could kind of start thinking, okay, how would I actually do this? And even when you're done, you can see like, oh, this is a pattern I've seen before, and this is how I would apply this other pattern to improve the performance. So I'm gonna go with like a really naive solution, probably like an n² solution, and it's probably not even gonna be correct. But I think that I would want to try to get something on the paper first, just so I can reason why it's challenging, I guess. So probably one thing. This is also a medium challenge, so like it's surprising that it's this complicated. But we could do return false. Actually return true. We're trying to find like an exception. If we're doing a palindrome function here, we do let I equals 0, I is less than input dot length divided by 2, I plus plus. If input sub I is not equal to input sub I, input dot length minus I minus 1. So yeah, my intuition tells me make this palindrome function. This is progress. You know, it's good to show that you at least kind of understand the problem. When you try to solve a problem in LeetCode, sometimes it took me hours. I don't know. Always end up getting help from GPT. I mean that's okay early on, because it's hard to recognize patterns early on, and the more problems you see, the more problems you solve, the better you get at recognizing the patterns and recognizing the language, like the art of converting like product requirements into code. But it's really good to take things step by step, or to like even draw out the process before you actually code it. So one thing that we could try to do is basically like try to make every single substring we could think of. And J will be I plus 1. Actually plus 2, because actually it's fine, we'll do 1. It could be part of the optimization when we hit it. And J is less than S dot length, J plus plus. And basically we would say like S substring equals S dot substring from I to J. Basically, like we're gonna be going through each index of the string, and then building all the different substrings that we can from the string. And yeah, it's a horrible idea, but will it work is the real question. And then we can worry about optimization. And so the other thing, what do we need to return? We have to return the string, as we've determined already. So we want to see if it's a palindrome. Actually, we don't even care. We don't want to run the palindrome code unless it is actually going to be bigger. So if the length is bigger than longest seen so far dot length and at the palindrome, then we'll say longest seen so far equals substring, and we'll just change the order of this and spell that correctly. So yeah, we have this code that determines if a string is a palindrome. Hopefully it's correct. and then we go through this string and make every single substring we can with that string, and see if we could find a palindrome longer than that. How we could run it to see, we'll probably get an error. Luckily we can just run it. We're not in TypeScript land, so we can't do that. And we do get a valid, we do have a valid solution, but we can think of ways to improve it. I mean, let's just submit it and see how we're doing against the rest of the world. Okay, well, we don't even pass through all the tests. So we could try to think about why that might be the case. The input is just the string A. So it's probably gonna be this. Seems so. Okay, so we're not going into the inner loop because I think we have to allow it to go to the end here to get every single substring. And the reason for that is because if it is a length 0, and then we do I is 0, j is I plus 1, I plus 1 would be 0 plus 1 is 1. And then we'll see if 1 is less than 1, which would have been false. So I think we have to do equals to, especially because we're doing a substring, we got to put the ending index of the substring, and that should be the length. So let's submit that. Okay. So at some point BB happens. So one thing that we could do is just make sure we're doing all the substrings, potentially. So let's just run this, look at the output, make sure we're doing every single substring. So BA, BAB, BAB. Okay, and then it should be AB, AB. There's more. We'll do a console log here, just so that we can say when I is changing. Ideally, these should be shorter and shorter. Right. It seems like we're not getting all the way to the end, which makes me think I don't know how substring function works. It is the end index, not the length. This is interesting though. I don't know why these both look the same. They get less and less, which is expected. But I don't understand why it's AD AD. I feel like it should be, or even this one is BAD. I feel like it should be, it should just be B, then BA, then BAD. Substring. It is a length. Oh my gosh. Okay, so apparently, I guess I'm calling the wrong function. If you can imagine. Let's take a look. Alright, that's what I was expecting. So, we're able to get some logging in there. And I think we could try to submit it again. Okay, so we did horrible. But that's okay, because we got a solution. Now this is medium difficulty. So I'm surprised that it is as hard as it is. I would have thought this would be hard. My instinct tells me that right now we're at like an n squared and cube algorithm. My instinct tells me we could probably do this with like dynamic programming or recursion. But it's important that we got a solution. Or we could try to think, how can we make it faster? Okay, we're at 426 milliseconds. So one idea that I have is do start n. We'll say start. This is still I. End minus start divided by 2. And this will be end. And basically, rather than making a substring here, we are going to pass in new arguments. And we'll say length equals j minus I. Put that there. And then we'll say s.substring I sub j. Only make the substring if we have to. So it's a little expensive to make a substring. Just a little bit. I mean, in theory, we could also I wish we could just return the length. We'll do this. Length equals 0. And rather than do substring here, we will also do, again, because it's expensive, just make a list, create a second list, reverse, compare the two, counting if they match. So I keep it till it breaks, start counting again. That's an interesting idea. You could definitely add, you could definitely give your own ideas. In terms of having a forward and backward version, I mean, we could just look at the end of the array rather than make like a clone of it. So like, I guess you can in theory have a virtual reverse list by just looking at the list backwards, using indices. I just want to kind of go hard with this idea of trying to optimize what we have here as best we can. Until, so we're at, let's see if this works. We're at 426, 19%. Okay, that's okay. Substring's not, yes, it's not. This should be yes. Run it. Okay. So we'll do a log there. I think the other thing is it's not just about counting, unfortunately. 1 to 5. 0 to 3. We could do this for now, just for logging. Let's just make sure that what we're seeing are actual palindromes, because I'm wondering if if our palindrome code is wrong now. This is not a palindrome, so is it? No, it's not the same thing forward as it is backwards. N minus I minus 1. I is start, I is less than half. Half is n minus start divided by 2. I'm missing something here. I need to add start back on, because this is just getting the length, dividing that length by 2, and then we have to offset it by where we're starting, so that we don't stop early. We're actually stopping early at the moment. But it's still giving bad output. BAB is correct. BAB is also correct. ABAD is not correct. And somehow, oh, BAD is not correct. What am I talking about? So let's also output, I don't know, let's output I, let's output J, and then we could think about why it thinks those are correct. BAB 03. Well, BAB is correct. Well, BAD is 25. So let's run this manually. So it's BAD 25. Actually, it's not BAD, it's this string. And 0, 1, 2, that's, yep. And then 5, yep. So let's think about this. What is the value of half? It's going to be 5 minus 2 is 3. 3 divided by 2 is 1.5. Plus 1.5 plus 2 is 3.5. Okay? Now, I equals start. I equals 2. half equals 3.5. Okay, so input sub I is 2. So 0, 1, 2 is b. If b is not equal to end is 5. 5 minus I. Ooh, interesting. We can't minus I anymore. Or we can't, if I starts at start, we can't minus I. Okay. Okay, so maybe this is 0. This is that. And this is start plus I. And this is end minus I minus 1. Okay, let's go through it all again. So half is 1.5. I is 0. Great. So input start sub I. Start is 2. I is 0, so it's 2, which is b. Is not equal to end, which is 5, minus I, which is 0, minus 1, which is 1, which is 4, which would give us the d, and then it would make it, it would see that it's not equal, and then evaluate that correctly. Okay, so let's run it now. Okay, our second case is failing now. Output is empty string expected BB. Okay. So let's go back to console logging this, and then we'll run it again. Are we hitting BB? That's the wrong case. No, that's the right case. Are we showing BB? BB is here. So we'll go to BB, and we're giving it CBBD. CBBD. And then the BB is 1, 3. Um, 0, 1, 2, 3. I'm a little curious about that. It seems like it's exclusive. I feel like it should be 1, 2, not 1, 3. CBBD. Oh, because substring is is it substring? Substra? Oh my gosh. It's substring. Okay. BB. I swear it should be 1, 2 though. Substring. The index is not included. Okay, the index is not included. Fine. Okay, so it should be 1, 3. Okay, back on track. Let's do it. Let's run the code. For some reason this is getting a false. So start is 1. End is 3, so 3 minus, let's clear this out. End minus start, 3 minus 1 is 2. Divided by 2 is 1. Okay. I is 0. Okay. It's I less than half. Half is 1, so yes, I is less than half. So start is 1. So, or sorry, start is 1 plus 0 is 1, so we get the B. We get the B on the left. And then end is 3 minus 0 minus 1 is 2. So we get the B. So yeah, that seems correct. So are we going into this then? Oh, this is not correct. Okay. Okay. Alright, we were at 426, 20%. Let's see if we did any better. Okay, we halved it, which is pretty good. We halved it by basically not doing a substring every time. So the question is, can we do even better than that? So part of me thinks we could get it a little bit better, even more so by figuring out early exits. Basically, if we did minus this, there's no point of continuing any longer. Like if we're on the last few characters and those characters are not enough to beat our longest scene so far, then we can exit early. So we're at 218. See if we do any better. Early exit. Barely better. As at this point where we gotta kind of come to the realization that it's our algorithm that's the issue and not an optimization with the algorithm, if we're this far away from the solution. So my first instinct is it's probably like a dynamic programming problem. Something to where you like create a table. Or even do recursion. I think recursion is an interesting idea. Is there a way to like save this? I'll do const old solution. Okay, so I have essentially two ideas in my mind. One is some kind of dynamic programming solution, and the other is recursion. Basically, what we want to do is try to splice the palindrome check in with the changing of the substringing, and try to do them both at once, and essentially like keep expanding. Something to the effect of, okay, here's my idea. assume every character is a palindrome and start from there and work your way out. Something like that. So look at each character and expand out until it's like no longer a palindrome. To some extent, I kind of wonder yeah, there's got to be like something to where S start end, right? And then we got to do like S dot map character index. And then we'll find we'll dot sort it. Maybe a b dot length minus a dot length. No, that's horrible. That's just lazy. Dot reduce max we're palindrome, and then we'll do this needs to be expand. S index plus 1. Basically, like I said, we assume that every character is already a palindrome. I'll say max dot length is greater than is less than palindrome dot length. Then make sure we're spelling this correct. Palindrome. Otherwise it's max. Something like that. And then the first string is going to be the default. But basically, we'll do like different kinds of expansions. We'll say left only is -1 for the start. Right only is +1 to the end. and then both. Something like that. Basically starting at a character and expanding out. We could do, actually we could do if s sub start is not equal to s sub end -1, turn empty array. Return oh, it's a little complicated. I want to try to avoid substringing if possible. To keep it simple for now, I will just substring. And then we'll expand s start end. Something like this. The only question is, how do you stop it from going infinite? Well, it never takes in less characters. It never unexpands, so hopefully the fact that that's the case isn't too bad. Let's run it. Check it. We gotta do a split of all the characters by empty. We'll do a flat map. Okay. Okay, we have a bunch of palindromes, that's for sure. And can I make this better? Can I not substring? We'll do this as an object. Okay, great. A is max dot end minus max dot start. B equals max dot palindrome dot end minus palindrome It's not really a palindrome, but it's fine. End. Return A greater than B. A, B. And then we'll return s.substring of max.start max.end. Let's do a console log of results. Is it substring or substring? String. It's so confusing. Okay. I guess we could do n minus start map it s dot substring I don't actually use the character, which is fine. See what this looks like. Okay, and I guess let's see what max looks like. Yep. Okay, 0, 1. So max A and B. Max, palindrome. I just make sure every A, B has a value. It does. Okay, it seems to think everything's length is 1. Oops. That'll do it. Okay. Let's clear up some of these logs. Run that, make sure there's no logs. Okay, we were at 211 milliseconds. Let's submit it. Oh gosh, it doesn't feel like it would be faster. Dang. Okay. We're gonna do if end is greater than s.length or start is less than 0. We also return empty array. Don't go out of bounds. ACAA. Darn. So we're saying that that is a oh, that's the problem. If I feel like I should only be able to go left one or right one. Yeah, I should only be able to go left one or right one if n minus start equals 1. Otherwise I have to work outwards. So if it's length 1, then I can try to do like a palindrome of length 2. If it's not equal to 1, then I can only keep expanding 2 at a time. That's my understanding, and that's because I probably start with these 3, I expand out 1 to the right, and then I match to the left, and it's like, yeah, that's a match, it's a palindrome. So okay, in my opinion, there's no way this will ever be faster than the code that I had. Which tells me that there's an even better solution. Okay, I think that I think I know when to admit defeat here. So we're just gonna return old solution of S here. Optimize question mark, submit it. Okay, and now I will just cheat and see what the best solution looks like. Wow. Interesting. They definitely do a nested for loop. And they definitely call it is palindrome. How is this run faster than mine? What? They even slice. How is this run faster than my code? If not, set has substring, set add substring. If they, oh my gosh. How is theirs faster than mine? What on earth is this? Are they trying to do like a regex? Let's see. This is okay. This is kind of crazy looking. So it looks like they're trying to do some crazy regex. Okay, so s.length array 2 times n plus 3. Fill it with zeros. T sub 0 is the caret. The last thing is the dollar. The second to last thing is a hash. Go through each item. Add hashes everywhere. Oh my god. What is this monstrosity? Wow. Okay, so this one had a similar idea to me. They had very similar ideas to me. Okay, I don't feel so bad because like I have code that should run faster than their code. I'm confused why it doesn't. Okay, well, we did optimize. Our solution is runs at twice the speed as when we started, so I'm gonna count that as a win.